So in this section, you will learn how to identify conditions that produce parallel lines. It's important to remember that all of the definitions that we are going to be learning in this section are definitions that you have learned in another form. Reminder, in Chapter 2, we discussed if-then statements. Within those statements, we identified the hypothesis and the conclusion, or P then Q. Remember in that same section that we also discussed the converse, and the converse reverses the hypothesis and the conclusion, or makes it Q then P. In mathematics, we use the term if and only if the converse of the statement is also true. So we talked a lot before about truth values, but in this case, if the original if-then statement is true and the converse is also true, then we can use the term if and only if. If we think about the corresponding angles postulate, we know that it says, if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. The postulates used in section 3.5 are the converses of postulates that you already know. So how do we get our converse? We still keep the if and the then, but we switch the P and the Q. So we take the ending and it becomes if each pair of corresponding angles is congruent, then two parallel lines are cut by a transversal. Again, we just flip the hypothesis and the conclusion. Here we have our first postulate, and it is the converse of the corresponding angles postulate. On the previous slide, we just looked at how it would be written in if-then, but now we are turning it into the converse of the corresponding angles postulate. And that states, in a plane, if two lines are cut by a transversal so that a pair of corresponding angles is congruent, then the lines are parallel. All we have done is taken the corresponding angles postulate and taken the converse. So if we look at a picture to support this, here we have angle 1 and angle 2 are corresponding angles. And if we can prove that angle 1 is congruent to angle 2, then we know line A is parallel to line B. Here is theorem 3-5, better known as the alternate exterior angles converse. In a plane, if two lines are cut by a transversal so that a pair of alternate exterior angles is congruent, then the two lines are parallel. So again, we are taking exactly what we have done in previous sections, but we are reversing the hypothesis and the conclusion. So here is our picture. So again, if two lines are cut by a transversal so that alternate exterior angles, angles 1 and angle 2, are congruent, then we know that lines A and B are parallel. So in a plane, if two lines are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the two lines are parallel. So if angle 1 plus angle 2 is equal to 180, they are supplementary, and then we know that line A is parallel to line B. In a plane, if two lines are cut by a transversal so that a pair of alternate interior angles is congruent, then the two lines are parallel. Again, this is the alternate interior angles converse because it takes the alternate interior angles theorem and makes it the converse. Here we have our picture. Angle 1 and angle 2 are alternate interior. If angle 1 is congruent to angle 2, then we know that line A is parallel to line B. We also have the perpendicular transversal converse, which states, in a plane, if two lines are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the two lines are parallel. So we know that if line A is perpendicular to line T and line B is perpendicular to line T, that means that these angles will both be 90 degrees. They will be supplementary. Then we know that line A is parallel to line B. So now we have 5 different ways to prove that two lines are parallel. We can show that a pair of corresponding angles is congruent. We can show that a pair of alternate interior angles is congruent. We can show that a pair of alternate exterior angles is congruent. We can show that a pair of consecutive interior angles is supplementary, not congruent. And we can show that two lines in a plane are perpendicular to a third line, which will let us know that the two lines cut are parallel. The following slides contain examples. So on this slide, we are being asked to identify any parallel segments and explain our reasoning. So the first thing that I want to notice is that angle YGR is 90 degrees and angle DRA is 90 degrees. And as you look at this, you should notice that they are corresponding angles. And since these are both 90 degrees, we know that segment GY is perpendicular to segment GA, and we know that segment DR is perpendicular to segment GA. And that is important because since they are both perpendicular, segment GY is parallel to segment RD by theorem 3-8, or the perpendicular transversal converse. Here is an example that has a little bit more complexity to it. Given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So if we start with angles 2 and angles 8, so first we identify angle 2, and then we identify angle 8. The next thing that we want to see is, are they on the same side of the transversal, or are they on alternate sides of the transversal? Well, angles 2 and angle 8 are on alternate sides of line L. So that makes L the transversal. Since L crosses lines A and B, we know that A is parallel to B by the alternate interior angles converse theorem. If we look at angles 12 and 14, we also want to identify, are they on alternate sides of the same line? So if we see 12 is here and 14 is here, they are on alternate sides of line M. So M is going to be my transversal, and since they cross A and B, those lines are parallel. And the reason is the alternate exterior angles converse. If we look at angles 3 and angle 11, we can see that angles 3 and 11 are on the same side of line A. We then know that line A becomes the transversal, and since A crosses lines L and M, those are the lines that are parallel. And 3 and 11 are corresponding angles, so our reason would be the converse of the corresponding angles postulate. If we look at angles 8 and 13, we can see that they are on the same side of line B, which makes B the transversal. And since B is the transversal and it crosses L and M, so B is the transversal and lines L and M are parallel, and that would be by the consecutive interior angles converse. Our final example is if I compare angle 6 to angle 8. Well, if I look at angle 6 and angle 8, I can see that they are vertical angles. And since my angles are vertical, no conclusion can be drawn about any parallel lines. I can see that B is a transversal, but I cannot make a judgment on whether any of the lines are parallel. Our final example involves algebraic expressions. I want to find the value of x so that segment BE is parallel to segment TS. Please note that the rules that I use to justify my equations have new names, but the concepts and relationships have not changed at all since the beginning of chapter 3. So if I look at segment BE and segment TS, I notice that segment ES is going to be my transversal, because even though it doesn't overextend, it does cross segments BE and TS. That lets me know that angle BES and angle EST are going to be consecutive angles, and they are on the interior of my shape here, so that makes them consecutive interior angles. We know that consecutive interior angles, when I add them, are supplementary or add up to 180, and I can use the consecutive interior angles converse theorem to prove this. Then I am going to use substitution, and instead of angle BES, I'm going to use 2x plus 10, and instead of angle EST, I'm going to use 5x plus 2, and I'm going to write this equation. Once I write the equation, I solve it by combining like terms, then I subtract 12, then I divide by 7, and I get that x is 24. The easiest way to see if these are correct is to substitute, and I substitute 24 for x. That is very bad penmanship. And I get 120 plus 2, which is 122, and 2x, or rather 2 times 24 plus 10 would be 48 plus 10, which would be 58. And if I add 122 and 58, that gives me 180, which lets me know that my answer is correct, that x has to be 24 in order for lines BE and TS to be congruent. That is the end of this lesson and the end of chapter 3. Please make sure that you bring any questions you may have to class.